Okay. Sorry, continuing, or should we go to Nick? Do you want to? Okay.
11.5.1. Does Maxwell's demon really violate the second law?
This is important. Dun, dun, dun.
In order to answer this question, we have to consider a few things. 1. Is Maxwell's demon alive? Answer: not necessarily. The demon is just a device that responds to the information signal, which means it can be automated for the tasks in a more efficient method than a living being. Additionally, the demon has to be placed inside the system, mostly for long intervals of time. So the best Maxwell's demons are probably automated devices and not alive. 2. How is a Maxwell demon activated? Answer: a sorting device that sorts the molecules cannot be bigger than the molecules themselves. Otherwise, sorting will not happen, as the device will interfere with the motion of the molecules. Hence, the Maxwell's demon cannot be bigger than the size of the molecules. However, a molecular-sized Maxwell's demon undergoes the same thermal motion as the molecules themselves, and so Maxwell's demon moves as a result. This is not productive, which means that we are very limited in our choices of Maxwell's demons. The device that transmits electromagnetic radiation and uses light as the sorting device is most likely an example of a Maxwell's demon.
Get it? Okay, next.
3. Does the Maxwell's demon violate the second law? Answer: no. For Maxwell's demon to work, it has to be enclosed within the container, and the only way for it to be as unobstructionist as possible is that it has to be 1. Sufficient size, 2. Mechanically reversible, and 3. Be able to sense molecules without disturbing their motion. As an answer to question 2 above, the best device will be something that radiates energy and senses the location of molecules through their reflection or radiation. This energy is absorbed throughout the system and can be shown to cause a greater entropy increase than any decrease caused by proper working of the device. Hence, the total entropy of the system increases, which is in line with the second law of thermodynamics. Hence, we conclude that Maxwell's demon does not violate the second law.
This is the best paragraph ever. Nick, do you want to continue, or Caitlin, do you want
I can do the interesting paragraph.
to? Okay.
And
Do the
an interesting fact to note is that this question, whether the second law holds or not, has been around for more than 150 years and is still an open question. The reason for such a device that violates the second law holds a lot of interest for the scientific community. This is because if we were to actually find a system where the second law was violated, we would get a system for energy generation that could, in principle, run forever and never produce any waste products. So far, we have not been able to find such a system, but the hope lives on.
So all you have to do to win the next Nobel Prize is to find a system that violates the second law. That's it. See, it's a simple task. You guys can do it. I believe in you. Caitlin.
You may be wondering why I went through this discussion. My purpose here was to illustrate the many problems we encounter when we deal with individual molecules. We still need to use our knowledge of the molecular microscopic nature of matter to help us understand the macro nature of matter. This need to understand the macroscopic nature of matter is what made the development of statistical thermodynamics necessary and even an obvious choice.
Get it?
11.5.
You continue, but what I'm saying is the reason why I made you go through this is because of the 2 words that were very important. And the idea is that the concept of these sorters and ordering and probability, if you were not aware of this story, just seems vague and mathematical. And that's what most textbooks do. So if you pick up a graduate level textbook, they'll tell you these words, they'll go into the math, and they'll never explain how things are related. This is why we spent half an hour talking about how counterintuitive some of these things might be, but they are not hard to understand once you get them. Good. Now ready to do some math?